Right, if you just watched my video on factoring review, one thing I forgot to cover and mention is sometimes, very occasionally, you are expected to know how to factor what we call a sum or a difference of cubes. So something like x cubed minus 8, it's called a difference of cubes because 8 is a perfect cube. It's x cubed minus 2 cubed. And this especially, the way it gets taught, right, most students think of it as a formula that you're just supposed to memorize. And the problem with that, of course, right, is if you're only learning by memorizing formulas, what happens if your memory fails you, which will happen, or if you do not use this for a while and then it comes up again, if you're just stuck, right? So let's look at a sum and difference of cubes in a different way, and maybe this will give you a better chance of factoring it correctly when it comes up than trying to memorize a formula. First thing I want to note is if you had a function like x squared plus 7x minus 8, notice that if you plug in 1 for x, you get 1 plus 7 is 8 minus 8 gives you that was going to be 1 squared plus 7 times 1 minus 8 gives you 0. And if you plug in a number and get 0, that actually tells you a factor. That means that one of the factors of this trinomial has to be x minus 1. Because if you think about it, the full factorization for x squared minus 7x plus 7x minus 8 is x minus 1 times x plus 8. Because if you plug in 1 and get 0 here, you ought to be able to plug in 1 here and get 0. And of course, if you do 1 right there, 1 minus 1 is 0 times anything will be 0. So if you know a number that you plug in here that gives you 0, then you know a factor. So back to here, x cubed minus 8, what's a number that you could plug in and make that equal to 0? Hopefully you see that if you plugged in 2 cubed minus 2 cubed would give you 0. So knowing that 2 gives you 0, what factor is guaranteed to come up with x minus 8? It's going to have to be x minus 2. And then there's got to be more. Okay. Now I'm leaving more room here because instead of using a formula, we're just going to think about this logically. Whatever this remaining factor is, I know that when I multiply x by something, I have to get x cubed. So that stands to reason this next factor has to start with an x squared. Also, I know that -2 times some number here has to get me to -8. Well, the only number that would work there is going to be +4. Right? -2 times +4 gives me the -8. Now, there is a middle term here. And how you can figure out what that middle term is to think about this. Let me use green. With what we've put down all so far, if we were to multiply this out, we have to get back to x cubed minus 8. These two terms, if I multiply them together, gives me -2x squared. Notice there is no -2x squared here, so I have to somewhere generate a +2x squared, which is going to come from x. So I want this to come out to be +2x squared. So what would x have to be multiplied to make that happen? It's going to have to be multiplied by +2x. You can check the remaining terms and multiply it all out, but it will work. This is the factorization for x cubed minus 8. Let's try another one. This is what's known as a sum of cubes because x cubed plus 125 is 5 cubed. So first, notice that if you plug in -5 cubed is -125 plus 125, it gives me 0. So I know if the first factor is going to be x plus 5. And if you might not even notice if it was x cubed minus 2 cubed, your first factor is x minus 2. When it's x cubed plus 5 cubed, it's x plus 5 as your first term. Okay, and now we're going to try to figure out that last trinomial. X times what is going to give me to x cubed? That's got to be an x squared. I like to do the last one next. What is positive 5 going to have to be multiplied by to get me to 125? That's going to have to be positive 25. And here's that key step for this middle term. These two terms, which I already know have to be there, gives me positive 5x squared, but there is no positive 5x squared, so I need to generate a negative 5x squared, which is going to come from x times what? That is going to be minus 5x. And I'm done. Let's try another one. 64x cubed minus 1. Sometimes it is helpful to think about what this is cubed. This is actually 4x quantity cubed, right? Minus 1 cubed. So following the pattern from the previous two, I know that my first factor has to be 4x minus 1. Right? X cubed plus 5 cubed, the first factor was x plus 5. 4x cubed minus 1 cubed, the first factor is 4x minus 1. Alternatively, you could reason that 1/4, if you plug that in for x, that's going to give you 1/64 times 64 is 1. 1 minus 1 gives you 0. So knowing that 1/4 plugged in gives you 0, your factor would be 4x minus 1, right? Because if you set that equal to 0, that's going to give you 1/4 as well. All right, let's see if we can figure out this last factor. 4x times what is going to get me to 64x cubed? That's going to have to be 16x squared. Negative 1 times what gets me to negative 1? That's just positive 1. And then looking at my middle, these two terms here, that is minus 16x squared, which is non-existent here. So what would this 4x have to be multiplied to get me to positive 16x squared? This is going to have to be positive 4x. All right, let's do one more. If you feel like you're getting this, see if you can pause the video and go ahead and try to factor 27x cubed plus 1,000. 27x cubed plus 1,000 is really 3x quantity cubed plus 10 cubed. So my first factor is going to be 3x plus 10. One more time, 3x times what gets me to 27x cubed? That has to be 9x squared. 10 times what gets me to 1,000? That is positive 100. And here I have 90x squared, positive 90x squared. So I want to see a negative 90x squared, which is what I would get if I multiplied 3x by, minus 30x. Gives me negative 90x squared. All right. Hopefully, you consider this maybe an alternative now to memorizing a formula. If you just reason your way to the answer, logic is always going to work better than memorization. And that's the way we should be thinking about math. All right. Thanks for listening.